Hey, today we're going to talk more about polygons, quadrilaterals, and a different part of the family, the trapezoids. So we filled out this part of the family tree in the last lesson, and I told you I'd leave this part till later. And so we're going to talk about trapezoids. This is a smaller part of the family tree. We have trapezoids, and then we have a special kind of trapezoid called an isosceles trapezoid. So we'll talk about the properties of their sides. What makes a trapezoid is that we have one pair of, and that should say opposite sides that are parallel. In the parallelogram, we had two pairs of opposite sides parallel. So what makes this different is that these two sides with no marks on them are not parallel. And you can see if I were to extend those sides, they'd eventually touch. This one pair of opposite sides are parallel. That's what makes it a trapezoid. An isosceles trapezoid has a pair of parallel sides, but it also has one pair of sides that are congruent. And you'll notice the pair of sides that are congruent are not the parallel sides. So in a trapezoid, these sides that are parallel we call bases, and the sides that are not parallel we call legs. So the legs in an isosceles trapezoid are congruent, much like the legs in an isosceles triangle. In any trapezoid, if you take a consecutive base angle, so here I have two bases, base 1 and base 2. These two angles here that are on different bases but are consecutive to each other will be supplementary. They'll add to 180. These two will be supplementary and add to 180. Same thing exists in an isosceles triangle. But in an isosceles triangle, the two angles on the same base, so these two angles both are formed by this base, and they're the same size. They're congruent. Two angles formed by this base are the same size, and they're congruent. And then we have one property for diagonals, and only in an isosceles trapezoid, the diagonals are congruent to each other. So that means that this diagonal here in yellow will be the same length as this one in green. So the one characteristic that usually pops up the most is this mid-segment or median. And it's if we have a trapezoid, any trapezoid doesn't have to be isosceles. Sorry, I need my pen. And I draw a segment in the middle, and it goes to the midpoint of one leg and the midpoint of the other leg. So that means those two pieces are congruent and those two pieces are congruent. We have a relationship that if we multiply the length of this mid-segment by 2, it'll be equal to the two bases added together. So again, the bases are the two sides that are parallel. So let's see that. My mid-segment is this minus 2 plus 7x, and my bases are 24 and 28. So if I multiply the mid-segment by 2, that should be equal to the two bases added together. I added them together to get 52. Divide both sides by 2, and I'm just going to solve this here, and I'll find that x is 4. Let's try another one. I have the mid-segment. I need to multiply that by 2, and when I do, it should be equal to my two bases added together, 22 and 70. So I'll multiply that mid-segment by 2, set it equal to my two bases added, and now I'm just solving. Notice I don't bother distributing because I know I can just divide both sides by 2 and I avoid distributing. Sometimes you might have to distribute, but when you can avoid it, I think that it helps limit mistakes. So I want you to pause here and I want you to try this one on your own, then press play for the answer. So there's my mid-segment. I'm going to multiply that by 2. On the other side of the equation, add the two bases. And then I'll solve. Again, I divided both sides by 2 here. Leave 5x plus 10. This side becomes 45, and you should get 7. So I want you to try one on your own before class. Let me make it a little bit bigger. I want you to find x here, given this mid-segment.